we're going to split this next target up into 2 days because it's a lot of information to cover. Today, we're just going to be talking about triangle congruence and how you can prove that. We went over congruence yesterday, so hopefully you have a base for your knowledge for this one. So anyway, the most popular congruent figures that you're going to see in geometry is going to be triangles. Okay, in many geometrical proofs, it may be necessary to prove that two triangles are congruent to each other. Okay, it might be simply to prove the triangles are congruent, or it might be to use the fact that they are congruent to gain additional information. Like we said yesterday, if two triangles are congruent, then their other parts are also congruent. All right, so if two or more triangles are congruent to each other, the triangles have three sets of congruent sides, as you can see here. So AC and DF are congruent, AB and DE are congruent, and BC and EF are congruent. And their angles are also congruent. So A and D, B and E, and C and F, all congruent. All right, so we've got those 6 facts. Okay, the order of the letters of the names of the triangle. If you're given that two triangles are congruent, then the order is the order in which they're congruent. So kind of like I touched on yesterday, if you have this information, then you know angle A and angle D are congruent. Angle AB, or not angle AB, segment AB and segment DE would be congruent. There are ways to prove that triangles are congruent, though, without having to prove all of that. Okay, there's certain combinations of angles and sides and whatnot that are enough to prove that the triangles are congruent. Okay, and once you've done that, you're guaranteed that all the rest of the parts are congruent. So let's start with the easiest one, side, side, side. Basically what it says that if you are given that corresponding sides of triangles are congruent, and you have 3 sides for all 3 sides of both triangles are congruent to the other 3 sides, the other triangle, then the triangles themselves are congruent. So like you're given in this diagram that AB and ED are congruent, BC and EF are congruent, AC and DF are congruent. So you would be able to prove those 2 triangles are congruent by side, side, side. The order would be important. So if I'm going to go AB, okay, I would have to, and if I go from A to B and then B to C, notice I have that 3 tick mark sides. So I go triangle ABC, so I would have to go DEF. Okay, you could say triangle BCA, that'd be fine, but then you would have to have triangle EFD. So hopefully you got an idea as to how naming these is important. Okay, another way is side angle side. And that's basically if 2 sides in the included angle of one triangle are congruent to the corresponding parts of the other triangle. Okay, included angle is basically you've got the 2 sides that are congruent, so the angle that is in between them, or where those 2 sides meet or intersect. So you can see I've got a side here and a side here, and the angle's right in between them. Same here, side, side, and an angle. Okay, SR and MP, those are congruent sides. NP, QS, those are congruent sides, and the included angles, angle P and angle S, are congruent. So you would be able to prove these 2 triangles are congruent by side angle side. All right, here, like just to make sure you understand included angle, in between the sides, in between the sides, in between the sides, so you get the idea. Another way is angle side angle. So if 2 angles in the included side of one triangle are congruent to the corresponding parts of another triangle, then again, the triangles are congruent. So again, we've got an angle, and the side that's in between them matches up with the angle and the side that's in between there. So if you have angle and a side in between both of them, and all those parts are congruent, then you can prove the 2 triangles are congruent by side or angle side angle. Okay, again, included side in between the 2 angles, in between the 2 angles, in between the 2 angles. Another method is angle angle side. So this one's a little bit different because if 2 angles and a non-included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So you could have an angle, an angle, angle, an angle, and then you've got a side out here that's not in between those two angles. And that's fine. Because if you have angle, angle, side, it still works. Trust me. You can try it if you want to get 3 sticks of varying lengths. Have fun with that. Or you can just take my word that this works. And one other thing I'm going to notice that isn't really covered here, but notice how I've got, and that should be an E there. Notice how I have these two. It looks like one big triangle. But actually, with this line here, it kind of splits it into two. And I've got this angle congruent to this angle congruent to this angle, but I've only got one side. So, but that side corresponds for each of the smaller one, even though it's the same side. We call this a reflexive property. When you're saying that something is congruent to itself for this purpose. I'm sure I'm going to have a lot of questions in class on this, and that's fine. This is just to kind of get you a base knowledge and get some notes on the paper for you. Okay, this one is a bit, you got to remember one thing about this, and that's that this only works if you're given that the triangle is a right angle, or a right triangle, meaning it has a right angle in it. Okay, so the hypotenuse and the leg of one right triangle are congruent to the corresponding parts of another right triangle. Then the right triangles are congruent, but they have to be the same ones. So we've got the right angle, we've got this leg, and the hypotenuse. Now the hypotenuse is going to be the longest side of a right triangle. Okay, so it's the side that is opposite of the right angle. So see, you've got your right angle here. It's the side that's opposite that. It's the side that's opposite that. So make sure that it's a hypotenuse that you have. Okay, because if you didn't have this, and let's say that it was that, even though it's a right triangle, now you're proving it by side angle side. So just pay attention because you are going to have to state why triangles are congruent. All right, these are the only combinations that work. Okay, there's other ones that don't work, such as side angle angle, side angle. That doesn't work. Such as this. Angle doesn't work because I can draw two triangles that have the same angles, but the side lengths are different. Like I can say this is 2, but this is 4. This is 5, but this is 10. This is 6, and I don't even know if these numbers would be accurate, but you get the idea. They can have the same angle measure, but they wouldn't have congruent figures. They would be similar, but not congruent. Okay, like I said, side angle doesn't work. Here's a perfect example of two triangles that have the same side measurements, the same angle measurement, but that look completely different. And if you were to measure this, which I know we can't do, we can't make assumptions, but we couldn't assume that they are congruent either. So they have to be congruent without a doubt. Okay, something to note. Once you have proven that triangles are congruent, all the remaining corresponding parts are also congruent. All right. So let's start with an example. Complete the congruent statement and write the postulate used. Okay, if the triangles cannot be proven congruent, which will happen, state not possible. So I have a side and a side, an angle and an angle. Now, remember I mentioned something earlier. Okay, we've got side angle, and then this part here is shared by both triangles, so we can say it's congruent to itself by the reflexive property, which means you would have side angle side. So MLK, if I'm going to do that, okay, since I'm starting here and going MLK, because remember the order is important. I have to start at K because we're starting at the small angle here, the one that is congruent. So angle M is congruent to angle K. So that would be the next one, and then we go across our congruent side to the L. So in this one, we'd go across our congruent side to the J, which leaves M. So K triangle KJM. Okay, in this one, again, we have that reflexive property. Okay, we've got a side, and then since this side is shared by both, we can say it's congruent to itself, so we have another side. So that's postulate side, side, side. And if we set NPR, we'd have to say QPR. All right, now this one. We have a pair of sides, and we can, again, use the reflexive property, but that's only going to do us so much because we don't have any other information. So we've got two sides, but that's it. We know nothing else. Okay, no angles, no other sides, no nothing. So we can say it's not possible. Okay, in this one, notice that it has this marking here. Now, when you have one square like that, letting you know it's a right angle, this is a straight line. And a straight line, don't forget, is made up of 180 degrees. So if this angle is 90, then this one also has to be 90 by default. They just usually only put one in. So now we have two right triangles, and their hypotenuse, whatever. You know what I mean. The two segments here are congruent. And again, reflexive property says that I can say that this is a congruent to itself, and that's a leg. It's a right triangle, so we can say they're congruent by hypotenuse leg, and PLK would be congruent to PLN. All right, and another one. So we have an angle. We can use the reflexive property again to say that this is congruent to itself for a side, and then another angle. So we can say angle, side, angle, and since T is congruent to V, okay, they've got to match up. So T and V, so since T was in the middle, V would have to be in the middle. And then the rest you've just got to kind of follow the same pattern with it. Now, one other thing, vertical angles are the angles opposite each other when two lines cross. So for example, if these two lines are crossing, this angle 1 would be a vertical angle to 2. And vertical angles are always congruent. So I could say that angle 1 is congruent to angle 2, angle 3 is congruent to angle 4, because vertical angles are congruent. This is important because if you have a diagram like this and you have these two sides, you could say, well, kind of like the reflexive property, you've got vertical angles, so this is congruent to this. So even though it's not in the diagram that you're given, it's one little bit of information that you can add in there. So now I would be able to prove these triangles congruent by side, angle, side. All right? So these triangles are congruent. Is ABC congruent to triangle ABC congruent to triangle DEC? Well, let's see. We've got an angle, a side, vertical angles congruent. I would say yes, because of angle, side, angle. Vertical angles help prove those second angles. Are these triangles congruent? Triangle ABC. No, that's not triangle ABC. It should be ABE and DEC. Are those congruent? Well, we've got two angles there that are congruent. We've got our vertical angles here that are congruent, but that's all we have, so that we don't know that they're congruent. Not possible. All right, do we know that triangle ABC is congruent to triangle DEC? We've got two sides. We've got our vertical angles. Side, angle, side. The angle is included between the sides, so yes, the triangles are congruent by side, angle, side. Again, vertical angles prove the angle to be congruent. All right, one more, hopefully. Are these two triangles congruent? Got your vertical angles, side, angle, side. Yes, by side, angle, side. Vertical angles proved it. And that is the end. So you can see why I'm splitting this into two. So hopefully this wasn't too much for you. I'm sure you have lots of questions. Make sure you ask them when you see me next, please. I want to make sure you understand this. This is where it can get a little tricky. Have a good one.